Hello, in this vlog we will talk about cost engineering for a paper producer. Why do I say cost engineering and I don't say cost accounting? Because when it comes to companies producing products with a very low margin, with a fierce competition on pricing, it becomes really imperative to be able to focus on determining in the most precise way your cost. Well, you know why. If you mark up too high, you might be out of market and lose business. If you mark up too low, or if your costs are not correct and are too low compared to reality, then you might sell under cost and make a loss. So it's so important to be able to determine precisely the cost, especially if you are operating on a custom market with requests very different from one another, and so it's really difficult to have a standard product. You have to almost quote in real time any specific request. So this is the issue facing a major producer of industrial paper roll. So how can you approach that? It's not possible to do it in the traditional way with a simple cost accounting. You must implement a detailed setup, an environment to determine precisely the cost based on the technical parameters for your paper. For example, the key parameters are surely the type of paper, and so the chemicals that will be included into the bill of material of your paper. Another important thing is the thickness. You know, if you have a very low thickness, let's say under 25 grams per square meter, your machine might run at up to 400 meters per minute. Whereby if you have a high thickness of, let's say, 450 grams per square meters, your machine might go down to 120, 150 meters per minute. So it means that the motor of your machines will run much faster, much slower, and so the consumption of energy might go even from 2,000 kilowatt hours up to 3,000 kilowatt per hour. So it's big excursions in energy absorption and then cost of energy, which is a very high proportion of the total cost of paper. Also, the cost of methane might vary a lot. If you have a paper with a very low content of humidity, let's say 3%, you have to extract a lot of humidity. So you might spend a lot of energy and methane to eliminate the water. If you're instead running a 5 or 6% humidity, it might be much easier because you will need less methane. So the methane consumption might go, let's say, from 140 cubic meter per tons of paper up to even 180 or 190 cubic meters per tons of paper. So you understand that these enormous excursions in this enormous range in the cost of energy and methane implies that you cannot really use average costing. You must use detailed costing, otherwise you might really suffer major penalty from selling overpriced or underpriced. Now, how can you do that? You need math. You need math because you need to determine what are the functions that correlates, let's say, the speed of the paper to the thickness, to the consumption of energy, to the level of humidity and the consumption of methane. So it is really about interpolation. So you need to take 1 year of detailed data from your production system, extract all this data, clean this data, and then use advanced statistics like the traditional system for multiple regression, or even network to determine the relationship between the different factors. So we are not about cost accounting, but we're really about cost engineering. We are applying math, we are applying inferential statistics to determine all the functions that will produce the cost of your product. So once we have all that, we can create a kind of configurator. That is a panel where you enter the key data of your paper, and then this panel, the system, what it does, it simulates the function of your production plan, determining the total consumption of energy, the total consumption of methane, the production rate, and based on the production rate also the fixed cost absorption and all the other costs, and determine precisely the cost of your product. This is so important. So this is cost engineering, blending together advanced math and statistics with the knowledge of cost accounting, understanding, the logic where you have to use a direct cost, where you have to use fixed costs. So you must have a strong background in cost accounting, but at the same time, you must have a strong background in inferential statistics and math. And this is the future of operational controllers, someone with a very solid background in scientific background, and then at the same time accounting background, able to give the right answer to produce, proper cost function that will help you in really achieving maximum performance. Because don't forget, it is important to be a very good producer, to produce quality products. But if you price it wrongly, even with the best product, you might simply go bankrupt. So pay attention, maximum quality, maximum efficiency, at the highest level of cost engineering.